So, welcome to the fourth lecture of this blockchain course. So, today we will talk about this conceptualization of the blockchain architecture and some interesting fact inside this blockchain design, and we will look into a few applications that can be realized using blockchain. So, uh, in the last class we have discussed about this permissionless model. So, we have discussed that a permissionless model, it works in an open environment and over a large network of participants, where the participants do not need to reveal their own identity. So, the users do not need to reveal their own identity to the other peers, and hence the users also do not need to know the identity of the others. So, the entire protocol works on a challenge response fashion. So, this kind of permissionless model, they are kind of good for financial applications like cryptocurrency, where you want to develop a currency mechanism that will not be under control of any single participants, and anyone in the network will be able to participate in the transactions by utilizing that currency. So, this kind of environment, they provide certain level of privacy and security. As I have mentioned earlier, that the system is tamper proof. It is extremely hard to make a change in the blockchain, but remember that it is not impossible. Based on the architecture that we have, it is always possible to change or to tamper the blockchain architecture, but it is extremely hard. So, with the current hardware devices that we have, it is nearly impossible to tamper a blockchain architecture. Now, regarding privacy, for Bitcoin, the transactions are pseudo anonymous, that provides certain level of privacy, not a complete privacy. So, in case of Bitcoin, the transactions which are sent, they are sent using some public key addresses. The concept of public key and the private key we will discuss starting from the next week, while we go to the details of different cryptographic mechanisms which are utilized for blockchain. So, this broadly, these public key addresses are cryptographically generated addresses which are computed by the wallet application. So, here in this example you can see that these particular things, they are the cryptographically generated addresses using this public key cryptography, and these addresses, from these addresses you will not be able to understand who are the actual users. So, you can just see that this user has transferred certain money, certain 0.0339 certain Bitcoin to this user, but who are those users are in actual real network, that you do not know, that you will not be able to reveal. So, it provides certain level of privacy, but remember it does not guarantee the complete privacy, because you are still able to see the transactions, although you are not decode the users, but you are still able to see the transactions. So, these addresses in Bitcoin, they are synchronous to an account in a bank. So, every address, they uniquely identify a user. So, for every user, one address is associated with him or her. So, the wallet, it listens for the transactions addressed to an account, and these transactions, they are encrypted by the public key of the target address. So, only the target node can decrypt the transaction and accept it, that the target node can understand that this particular transactions is intended for myself, and the wallet accept the transactions and publish that availability of this much amount of Bitcoin to its his or her wallet. However, the actual transaction, as I have mentioned, it is open to all for verification. So, Bitcoin makes these things public because anyone can verify the transaction. So, user IDs are constant. So, this ID, once it is generated, this will remain forever until you change the wallet or until you lose your wallet. So, whatever transactions that will be done by a same wallet, it will have these addresses. So, the addresses are unique. Based on that unique addresses, you can validate the transaction, but you cannot reveal or you cannot find out the actual identity of the corresponding user. Now, there is one interesting fact in blockchain mining procedure. So, in the blockchain mining, if you remember that what we discussed, that multiple users, they are simultaneously trying to mine a block. they are simultaneously trying to solve a mathematically challenging problem based on this challenge response architecture that I have discussed in the last class, and based on that they are trying to find out a block. Now, each of these blocks are generated in individual time instances. So, this is say T1, at T1 you had the block 1. Now, at T2 again multiple users are trying to generate the blocks, and assume that 2 users have found out the blocks simultaneously or nearly at the same time. So, what will happen? Both will add this block to block 1. So, now I actually have 2 parts from block 1. From block 1 either I can go to block 3 or I can go to block 2. Then at time 3 again whenever the new transaction comes, the users will try to again mine that, the miners will try to mine that and add the new blocks, and at that time instance it may happen that 3 other users, they are able to successfully find out the nonce which will have the corresponding difficulty in the hash function. They will able to get it at the same instance of time. Now, if they are able to get it at the same instance of time, so there are 3 other blocks, and now these 2 users, they have this block as the previous block. So, they connect the block with this as the previous block. Another user, it connects the block, this one as the previous block. Now, what happens in case of a blockchain network, that whenever you are adding up a new block to the blockchain, then you are broadcasting that updated blockchain to your neighbors. Now, a neighbor, if you look into a peer-to-peer architecture, a particular neighbor can receive the block from multiple other peers, and whenever it finds out that well there are multiple copies of the blocks which he or she has received, then it accepts the block with the longest chain. So, it only accepts the longest chain. So, whenever say another user comes here, it assumes that this is the longest chain. So, then whenever the next block is mined, that get added to block 5. So, once block 7 gets added to block 5, then this particular chain becomes the longest chain. So, this particular chain becomes the longest chain. Now, the subsequent block will add it to block 7 and that will not be added to block 6. So, again at this time instance, say this is T1, T2, T3, T4 and T5. So, at this time instance again 2 miners can mine the block simultaneously. So, there can be 2 other blocks. So, that way in general a blockchain is not a chain, rather a tree. We can represent it as a directed tree, and in that directed tree whatever be my longest chain, that is accepted as the current chain. And in some time instance it may happen that you have 2 different chain, both of them are having same length. So, for example, in this case this chain and this chain, all the 3 chains are of same length. So, whenever a miner has this kind of option, it randomly selects one of them. And ideally what it happens, then whenever people are propagating the updated block to the neighbors, it is expected that some chains will get invalidated over time. So, the exact procedure of invalidation again we will discuss when we will go to in-depth discussion of these mechanisms. Now, that is the idea. Whenever this user gets 2 different blockchain, 2 different versions of the blockchain, it always accepts the longest chain. So, this was the longest chain based on the current blockchain. So, it has a path length of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. It has the length 6. So, it will accept that chain. Now, whenever a new block is mined, during that time, that new block is always added to the longest chain. So, whenever the new block is mined, so this particular chain is the longest chain. So, the new block will get added to this longest chain. So, that way whenever the blocks are getting propagated and multiple users are mining the data simultaneously, and you have possibility of having multiple chain together. So, all these things we take a name from operating system and we say that a new chain has been forked, just taking into the concept of process from operating system, we say a new chain has been forked, but whenever a new chain gets forked, if that is not the longest chain, that is not used any further. always the longest chain is getting used to add up the new blocks to our existing blockchain. So, the other blocks which are there, we call those blocks as the orphan blocks. So, those blocks are not part of the longest chain. So, here this green chain is the longest chain. So, all the blocks in the green chain, they are considered as the valid blocks, and all other blocks they eventually becomes orphan blocks. Although in this case this also becomes the longest chain. So, you can consider this chain as well. So, one of the chain from root to leaf, whichever is the longest chain, or if there are multiple chains, then out of the multiple chains one of the chain you consider as the main chain, and other chains the blocks in the other chains they will be considered as the orphan blocks. Now, let us look into few applications of blockchain. First, we will look into multiple cryptocurrency applications. So, once the Bitcoin was developed in 2009 by Satoshi Nakamoto, which was the first decentralized ledger currency which had taken the concept of blockchain as its backbone. Multiple other such cryptocurrency mechanisms came into practice, and people have developed multiple types, different type of mining and consensus algorithms which have been part of their individual currencies. So, in 2011 we had the another cryptocurrency called Litecoin, which used a concept, a hashing algorithm called script, which is a lightweight hashing algorithm that had been utilized in Litecoin. Then in 2012 there is another cryptocurrency called Bitcoin. So, the Bitcoin it focused on user privacy through impassive and anonymous transactions. So, in case of your standard Bitcoin all the transactions are visible, but in that case they have a way to, they have designed a way to hide the transaction, but still a mechanism to validate the transactions. Then in Peercoin, which came in 2012, they used another consensus algorithm along with proof of work, which is called the proof of stake. So, the details of the proof of stake we will discuss while we will concentrate on different kind of consensus algorithms. So, this Peercoin it has taken POS proof of stake as its mining algorithm. Then in 2013 there was this Emercoin. Emercoin it developed an architecture to store small data which can be utilized for the purpose of domain name system validation, public infrastructure, SSL infrastructure, to implement this kind of system which requires a small database, and for them this Emercoin it provided a trusted storage architecture. Then we had something called Ripple, which is a cryptocurrency which was designed for peer-to-peer debt transfer. In 2016 we had seen Webs, which is an open blockchain platform to develop applications for high volume transactions. It supported higher throughput or significantly higher throughput compared to Bitcoin, but it has a limitation like it cannot support a large number of nodes in the network. That is indeed a trade off which we will explore later on. Then there was a currency called Omni, which came in 13, which used both as a digital coin and at the same time a communication platform, which was built on top of the Bitcoin blockchain. And then 13 there was Gridcoin. The Gridcoin was the first cryptocurrency which is linked to citizen science. So, citizen science is an interesting application which is similar to that crowdfunding application that I have mentioned while talking about this concept of smart contract, where a group of people comes together and collectively they complete some task. So, this kind of environment in Berkeley Open Infrastructure Network Computing, they termed it as citizen science. So, this Gridcoin that was utilized to support citizen science platform over a decentralized architecture. So, these are some of the cryptocurrency applications which are developed over years. There are multiple other applications people are exploring or people have already developed, and those are the basic advantage of those applications are that they are completely built on a decentralized platform where you do not require a centralized storage architecture, but yet you can support multiple security and privacy, then this kind of consensus, this kind of properties over the system. So, there is an interesting site that I have shown you earlier, the Bitcoin block explorer. So, if you go to this site blockchain.info, you can see the current blockchain which is behind the Bitcoin architecture. So, this snapshot I have taken during that time, that was the height of the block. So, that was the this was the height of the block 514498, and you can see that how much at what time that block was get added. So, from this block to this block it took 10 minutes, then this block to this block it took 3 minutes. So, at what time the block was mined and block was added to the network. Now, all of these blocks may not be the part of the main chain, main Bitcoin blockchain, but it may be some blocks are maybe the orphan blocks. So, by going to this blockchain.info, you can see which are the blocks which are part of the main chain and which are the blocks which are orphan blocks. Now, in blockchain 2, we are little moving from this concept of permissionless model to something called a permission model or a private model. So, in case of a permission model or a private model, so this concept of blockchain, the industry people they explored that this concept of blockchain, it can be applied beyond cryptocurrency. So, this underlying notion of consensus, security, distributed replicated ledgers, they can also be applied to many kind of closed or permission network settings. And interestingly, most enterprises use cases, most enterprises use cases, they consider this kind of closed environment or a permissioned environment, where you have some few 10 to few 100 number of known participants who are participating in the consensus procedure, and or who are participating in that application. They want to share some information among themselves, or they are collectively designing some kind of applications which will perform some predefined task. So, from there we have that concept of permission model of blockchain, which came as a part of blockchain version 2. Now, in permission blockchain, the interesting fact is that the users are known a priori, because your environment is closed. Now, when your environment is closed, you may not require a consensus algorithm based on challenge response, which has its own disadvantages, like it takes a significant amount of time to commit a block in the existing blockchain, because the consensus takes a significant amount of time and you have a restriction on the size of the block. So, in case of permission blockchain, you can leverage the existing distributed system consensus algorithm, which was developed in the last 30 plus years, and those kind of algorithms, it provide a stricter notion of security and privacy, and this supports greater transactional throughput based on the traditional consensus algorithm, like this Raft consensus, Paxos, Byzantine fault tolerant consensus. All these different kind of consensus algorithms we will study later, but this type of consensus algorithms, they provide significantly higher transaction throughput compared to the standard proof of work mechanism, which is a challenge response based mechanism and which is incorporated in Bitcoin architecture. Now, this kind of permission blockchain, they have multiple applications. One application can be in the direction of asset movings of tracking. So, here are two examples. See, in one example, the assets are moving from multiple banking branches. Say they are kind of secured assets, like the money which is moving from multiple banks or even the branches of multiple banks, and you want to track that what is the movement. So, when it is moved from say bank A to bank D, then bank D to bank B, then bank B to bank E, you want to monitor or you want to keep track of that, and you want to keep track of that in such a way so that bank B cannot deny in a later time that it has not received that particular asset. Another application of this kind of asset movement can in the supply chain, where you have multiple manufacturers and the manufacturers sending the asset to the shipper is sending the assets to the distributor, and the distributor is sending the asset to the retailer, and you want to track the path that how a particular asset has been moved from manufacturer to shipper to which distributor to which retailer, and in such a way, in a secure way, that distributor A will not be able to deny later on that he or she has not received that particular asset. So, that way there are multiple applications, and in this kind of particular application we can rely on the blockchain environment to design a nice solution like the provenance stacking, where you want to prove that a particular distributor or a particular person or intermediary has indeed received the asset. So, you are trying to track the origin and the movement of such high valued items in a supply chain, like say the luxury goods, the pharmaceuticals, the cosmetics, the electronics, like that. Now, how you can realize that in the blockchain? Like when the high value items is created, a corresponding digital token that can be issued by a trusted entity, because here we are considering a closed environment. So, all the supply chain, all the stakeholders in the supply chain environments, they are known a priori. So, they can get this kind of digital token which acts to authenticate its point of origin. That means the asset has originated at that point. Now, every time the physical item changes the hands or changes its location, the digital token is moved in parallel. So, the real world change of custody, you can precisely mirror it inside a chain of transactions on the blockchain. So, as and when the asset moves from one supplier to one distributor to the next distributor, you can basically put a corresponding token in the blockchain, and that particular chain, that particular series of transactions will tell you that how the assets has actually been moved. And because the information has been stored inside the blockchain, no one will be able to deny it later on that he or she has not actually received that particular asset, or he or she has not forwarded the asset to another party. So, this token, it is acting like a certificate of authenticity, which is far harder to steal or forge than a piece of paper. So, if you are writing something on a piece of paper, it is easier to forge that compared to if you are putting it inside a blockchain. And again, the good thing here is that you do not have a centralized environment, that you can you do not need to rely on a centralized architecture to implement this kind of concept. Now, another interesting application of this blockchain is the implementation of a distributed web. So, there is this concept called interplanetary file system. So, interplanetary file system actually implements a distributed web architecture, where it combines the small storage elements or the small storage which is available in our individual devices, and by combining the small storages which is available to different users, you can actually construct a large storage. And the idea here is that whatever data I have in my storage, possibly or in most of the time, that particular data is also available to multiple other users. Now, if you can connect all those users together, then what you can possibly do that, well, the original data remains to only one users, and for other users you do not need to store that data. What you can do, you can just keep a pointer that this data is available to this particular user. Now, to make it fail safe, you can just keep some multiple replica of that data to few other users. So, that way this IPFS, it can provide high availability of service, whereas avoiding the replication of the data or the replication of the files over multiple users. So, this way this IPFS works. So, you can go to this site ipfs.io, and that is an open source project. So, you can just explore that, or you can play with this IPFS tool. So, in IPFS, each file and all of the blocks within it, they are given a unique fingerprint through which you can identify a specific file or a specific block inside the file, which is based on the cryptographic hash function. Now, IPFS, it removes the duplication across the network to save the storage space and track version history for every file, that if a file has been changed, so it makes another replica of that file, so that if some users wants the old version of the file, he or she will be able to still access the old version of the file. And each network node, it stores only the content it is interested in, and some indexing information that helps to figure out that who is storing what. So, when you are making a lookup on the files, so you ask the network to find nodes which are storing the content behind that unique hash. So, every file is now have a unique hash function. By using that unique hash function, you can make a lookup that which user has that current file, and every file that can be found by human readable names. that IPFS also implement it using a decentralized naming system called IPNS, interplanetary naming system. So, what it does, this IPNS maps the names, the human readable names to the corresponding hash entity. So, you can even search with that your human readable name. So, that way this indexing information is basically stored inside a blockchain. And what is the advantages of that? Say if you are owning a file, if some file is, you have some file, so that information is there in the blockchain and everyone has that copy of the blockchain. Now later on you cannot deny that you do not own that file. So that way IPFS ensures the availability of the file even in the presence of failure, and it provides a secure way or authentic way to search the file over the internet. Then there is one interesting platform to implement this kind of permission model of blockchain, and this kind of permission model of blockchain which is nowadays very important for the industry perspective to implement different kind of business application. So, a permission blockchain framework, it provides an enterprise gate foundation for transactional application. So, Hyperledger Fabric is a permission blockchain framework. So, it contains a shared ledger which supports smart contracts and ensures security and integrity of the recorded transactions. Now, this concept of the Hyperledger Fabric platform is little different from Bitcoin and Ethereum. Ethereum is another platform for implementing blockchain application using Ethereum platform you can implement decentralized applications, or they are called as dApps. So, you can implement your own dApps using Ethereum platform. So, the concept of Hyperledger Fabric is little different from Bitcoin and Ethereum. In comparison with Bitcoin and Ethereum, Hyperledger Fabric, it supports strong privacy and confidentiality of the transactions, which is not supported in case of Bitcoin or Ethereum. So, another interesting feature of Hyperledger Fabric is that it supports the notion of channels. A channel, you can think of it is a subnet of peers within the network who wants to share the information confidentially. Now, that is important for the business perspective. In case of business perspective, everyone should not have the same visibility of the data. Some group of users or some group of peers has one level of visibility, some other group of peers had some other level of visibility. Say one group of people can see some 10 files, another group of people can see some 20 other files. So, using this concept of channel inside Hyperledger Fabric, you can implement this kind of architecture where you can provide or you can support this kind of partial visibility or restricted visibility, which is very important for business applications or for the smart contract applications. Now, from the consensus perspective, because it is a closed environment or it is a permission environment, so Fabric does not have any notion of mining, rather it used the notion of the standard distributed consensus algorithm under a closed environment. So, this is typically a Fabric network architecture. So, in a Fabric network, say you have these blockchain users. So, the blockchain users first take a membership from a certification authority, which makes the environment as closed. So, whenever a blockchain user, if it do not have a certificate at that time, whenever it is participating in this blockchain application, it can contact with the certification authority and get a certificate by enrolling his name. That way we are making the environment closed, and then it can invoke, there is something called chain code transaction. So, this chain code transaction it implements the basic blockchain architecture in case of a permission model or in case of a closed model. So, they can invoke the chain code transaction and put the transaction inside this blockchain platform which is maintained by Fabric. So, in later classes, Praveen will give you the detailed design and architecture of this Fabric platform with some applications and coding, that how you can implement your own application over the Fabric platform. So, as we will progress on this course, we will go to the details of this blockchain Fabric platform as a hands-on use case. So, in summary, So we have seen that there are two models of blockchain network. One is the permissionless model for open environment, and another one is the permission model, which is for a closed environment. Now this permissionless model, it is suitable for open control free financial applications like cryptocurrency, whereas this kind of permission model which is suitable for business application like smart contract. So that is all for this week. So in this week, in summary, we have discussed about the basic notion of blockchain and what are the different technical aspects that we need to study to understand the functionality of the blockchain. So I have given you a brief overview or a bird's eye view of how the blockchain environment actually works, and what are the different applications both in the permission environment as well as in permissionless environment that you can realize using the blockchain architecture or the blockchain environment. So in the next set of classes, we will go to the detail of these different mechanisms. So we will start looking into the basic cryptographic functionalities which are useful for implementing a blockchain architecture. At the same time, we will look into the mining algorithms and the consensus algorithms in further details, and we will look into that what are the different ways people are exploring this blockchain system to make it more scalable or more useful for different kind of government as well as industrial applications. So we will meet again in the next classes. So thank you.